All right, today we're going to be talking about things that are parallelograms that are also something else. That's perfectly okay for something to be a subset of something else. The best illustration I can think of to tell you why this is okay is, for example, if you live in Alabama, that identifies the state that you live in, and you get all of the rights and protections that the state of Alabama affords you. But don't you also live in the United States? And aren't there some other benefits you get for just being a United States citizen? Or isn't there some other things that are true about your situation because you're not a United States citizen? That's the way it is with these figures. So there's a parallelogram, but part of being a parallelogram, you can also be in a rectangle or a rhombus. And all of the things that are true about parallelograms are true for rectangles and rhombuses as well. And then if you take a rectangle and a rhombus and you put them together, you get a square. So a square has all the properties of a rectangular, a rhombus, and a parallelogram. A rhombus has all the properties of a parallelogram. A rhombus does not have the properties of a rectangle. A rectangle does not have the properties of a rhombus. Does that make sense? So I kind of made a little diagram of how it all fits together. If I say something's a quadrilateral, that means it's a four-sided figure. If I say something's a parallelogram, well, we already know 6 things about a parallelogram. Those 6 things also apply to rhombus, rectangle, and square. And then today we're going to learn some things that apply to a rhombus, and we're going to learn some different things that apply to a rectangle, and all of those things a square has. So what is a rhombus? A rhombus is an equilateral four-sided figure, a four-sided figure where all the sides are the same. A rectangle is an equal angular four-sided figure where all the angles are the same. And a square is a combination of both of those, also called a regular figure. All right, so what's cool about the rhombus? In the rhombus, we know that the diagonals will always be perpendicular to each other. And we also know that the diagonals will bisect the angles. So what does that mean? Well, if I take a rhombus, how do I know this is a rhombus, by the way?
Because all the sides are equal.
Right, it's equilateral. It's an equilateral four-sided figure. By the way, you can tell that it's a parallelogram because opposite sides are congruent. And in fact, opposite sides, all the sides are congruent. So, it's a parallelogram. What does that mean about its diagonals if it's a parallelogram? What do we know about the diagonals of a parallelogram? They bisect each other. So, just because it's a parallelogram, I know that. And then because it's a rhombus, I also know that. And I know this. And I know this. And I know this. So being a rhombus has the added bonus of these lines right here are perpendicular and these angles bisect each other. By the way, technically this rhombus is divided into 4 congruent triangles because this triangle right here is congruent to this one by side angle side is congruent to this one by side angle side is congruent to this one by side angle side. Isn't that neat?
Can it also be angle side angle?
Yep. Angle, side, yeah, if I ignore the congruent sides in between, then yes. Angle, side, angle. Did you say angle, side, angle, or angle, angle, side?
Angle side angle.
Yeah, you could do either one of them. Technically, you could do side, 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 so that should really have 3 marks on it. They're all kinds of congruent to each other. A rectangle has the added benefit that its diagonals are congruent. Now, its diagonals are no longer perpendicular. Its diagonals no longer bisect the angles because it's not a rhombus. But its diagonals are congruent. And what that means is that if this whole line right here, AC, is congruent to this whole line right here, DB, and I bisect DB and I bisect AC, now all of the individual parts have the same length as well. So when you make the diagonals in a rectangle, you're actually dividing it up into 4 isosceles triangles. Pretty neat, huh? So that's the new information that I'm telling you today. We've got parallelogram, we've got, as part of a parallelogram, we've got rhombus and rectangle. Rhombuses have certain extra properties. Diagonals are perpendicular, you need to know that. Diagonals bisect, you need to know that. And then in a rectangle, diagonals are congruent. You need to know that. What do you think is going to be true about a square? If a square is a combination of a rectangle and a rhombus, what's going to be true about a square? Right. So in a square, everything works. All right. So let's take a look at some exercises where we would apply these problems. So here we have a figure. By the way it's marked, and knowing that it's a parallelogram, what can we say? So since it's a parallelogram, what do we know about opposite sides? So is it okay for me to put a 1 mark on this? Is it okay for me to put a 1 mark on this? In a parallelogram, what do we know about opposite angles? So is it okay for me to make this 90 degrees? What do we know about consecutive angles? So what plus 90 equal 180? Oh, look, that's 90. What about this one? So what does that look like? Square. So by knowing it was a parallelogram and a couple of pieces of information, I was able to determine exactly what kind of figure it is. Square is more specific than parallelogram. What about this one? If this one's a parallelogram and this is 130, what do we notice about this? What's this going to be? So what's this one going to be? Why 50? Right. Consecutive angles are supplementary in a parallelogram. So what kind of figure do you think that is, where the sides are the same but the angles aren't? Rhombus. Rhombus! Everybody okay with that? Does this seem hard? The key is knowing what you can do. Knowing that diagonals would be perpendicular if it was a rhombus. Knowing that diagonals would bisect each other if it was a rectangle, or if it's a parallelogram. Diagonals would be equal if it's a rectangle. Opposite angles are congruent if it's a parallelogram. So we need to know all of that stuff, those 6 things I had you write down at the beginning of class. We need to know all of that stuff to be able to work these problems. That's why that was important. All right, let's take a look at this. Let me clear out my previous work. JKLM is a rectangle. If JL is 4x minus 12 and MK is x, can we find the value of x? So I would sketch a rectangle, JKLM, and notice that I use the letters in sequence and I just go around the corners of the quadrilateral. I draw the 2 diagonals. Since it's a rectangle, what do we know? And the diagonals are JA and MK, right? So if they're congruent, they're equal. MK is funny. Oh, JL. JL and MK. So they're equal, right? Yeah. So can I substitute 4x minus 12 and x? And then solve by subtracting 4x from each side, and then dividing by -3. Well, I can definitely find the value of x. And if MK is just equal to x, then that's just going to be 4. And I hope JL turns out that way. JA is equal to 4x minus 12, which is 4 times 4 minus 12, 16 minus 12. Yep, that's 4 too. So the value of x was 4, and the value of each diagonal was 4. So the equations might be a little bit more difficult to solve than this, but the idea is the same. You set the 2 diagonals equal to each other and plug in. Everybody okay with that? All right. Let's take a look at a situation where you've got something going on, but it's wrong. And you have to figure out why it's wrong. So in this particular problem, a classmate of yours said that, hey, we've got this rectangle right here, and that means that these two angles are congruent, so I'm going to set them equal to each other, and I'm going to solve and get x is equal to 2. What's incorrect about this problem?
Because that doesn't bisect the angle.
Right, in a rectangle, the angle doesn't bisect the angle. What does the angle do? What does the diagonal do?
It's just congruent to the other.
It's just going to be congruent to the other diagonal. What type of figure has it where the diagonal bisects?
A rhombus.
A rhombus. So this is not a rhombus. So we would know that this whole angle right here is equal to what?
9.
So these two angles are complementary, not equal. So don't just because you see an angle or see a couple of angles, go through and just start setting everything equal to each other just because we did one problem where that was true. Think about the situation. Think about the rules that apply to the figure. And think about what you can do to set up your equation. Really, that's one of the things that we're really trying to do, is we're trying to help you think about how you set up an equation. So the error here is these two angles aren't congruent. Any questions about that? All right. Here's your homework.